Find the NPVs for sine theta divided by tan theta minus 1. When looking at the restrictions, you want to look at the individual trig functions and the expression as a whole. Sine theta does not have any restrictions. Tan theta does have a restriction. To help us find our restrictions, we can write that as sine theta over cos theta, and remember that you cannot have 0 in the denominator, therefore cos theta cannot equal 0. I've got the circle drawn here, so if we look at where the x values linked to cos theta are 0, that occurs at pi by 2 and 3 pi by 2 and continues around. So pi by 2 plus the distance of pi n. So theta cannot equal pi by 2 plus pi n, where n is the element of integers. Okay? Then let's look at the expression as a whole. Tan theta minus 1 is in the denominator. That cannot equal 0. So tan theta minus 1 cannot equal 0. Isolate tan theta, so tan theta cannot equal 1. We are not going to find that on our unit circle anymore. Remember that on your special triangle, our pi by 4 angle, if we do tan, it's root 2 over root 2, so it's 1. So our reference angle is pi by 4. So we're really solving as if tan theta was 1. 1 is positive in quadrant 1 and quadrant 3. So in quadrant 1, theta would not be able to equal pi by 4, and in quadrant 3, theta cannot equal 3 pi by 4. Let's look at seeing if we can combine this. Helps to visualize where these are. Pi by 4 would be in quadrant 1 exactly midway. And, sorry, I wrote 3. 5 pi by 4. 5 pi by 4 is in quadrant 3, exactly this. This is a distance of pi. Therefore, if we take pi by 4 plus the distance of pi n plus the distance of pi n, we can combine these. So our second part of the restriction, I'm going to write it above here with this one, is theta cannot equal pi by 4 plus pi n, where n is the element of integers. There's no way to combine each of these, so we need both of these as part of our answer.